But thank you all for coming to my talk. My name is Chance Strickland. I'm going to tell you about building fast backends for faster front ends with Remix. Now, first of all, anybody know what Remix is? All right, we got my work cut out for me today. I normally go to JavaScript conferences, and I've learned that this is like half .NET people. And I also learned that I live in a bubble, and so I don't know what's going on out there. They don't know what's going on here sometimes, and so like when you're just on JavaScript Twitter all the time, you don't actually know what's really happening in the world. So, oh no, we're gonna have this problem, aren't we? All right, yep. Is there any way to, all right, 5 seconds. Let me fix my settings so that this screen doesn't shut off. All right, I'm not gonna do this because it's gonna take a bunch of time, so I'm just gonna have to hope that this doesn't continue going off on me. All right, so jumping in. I'm gonna start with a little bit of history, as every good tech talk does. I'll talk a little bit about the before times when front-end developers and back-end developers had, I think, very different, clearly defined roles. We had our own responsibilities. Our code was often in separate code bases, often written in different languages. And the vast majority of websites at the time were a lot simpler, mostly content driven. So this wasn't that big of a problem. You had your front end specialists and you had your back end specialists, and everything was somewhat clear. And for your more highly interactive code bases, they were often not websites at all. Our interactive sites, if you remember, the good old days were all Flash applications embedded straight into your page. And of course, Flash disappeared, and demand for building native-like apps on the web increased. Sorry, I'm having all kinds of technical problems here. Give me 1 second. There we go. Now, existing technology for building highly interactive web applications was somewhat limiting. And the tech that we did have was kind of clunky and uncomfortable to work with. And so our code got really messy, and it got really hard to start keeping track of more complex state. And back-end languages, they gave us the primitives that we needed to easily respond to async requests. When we talk about highly interactive projects on the web, apps on the web, what we generally think of as asynchronous requests. Right? You request some data, you get some data back without going through the whole page refresh cycle. That's what gives you that very native-like experience. And so we had what we needed on the back end. We had what we needed on the front end in JavaScript. Anybody remember Ajax? Of course we do. Anyone constructed an HTXML request API? Oh, pre-fetch API. We all just said npm install Axios and moved on with our lives. Yeah, this was front-end asynchronous request handling. And it kind of sucked, not gonna lie. So this made life as an app developer a bit challenging, but if you were an open source developer working on the web, it was kind of an exciting time. There was a lot of innovation, there was a lot of experimentation, and people trying to actually solve these problems without waiting on the web to catch up. And this brought about the advent of JavaScript frameworks, and it made developers more productive building their web apps. Now, this is not a talk about the history of web development, but I do want to mention all this so that we can at least stop and talk about two specific points that I think were seismic shifts in the industry. And the first one is Node.js. Now, Node sort of changed the game for the back end on the web. And it also had huge implications on front-end developers. Now, our front-end code, all of a sudden, can interface directly with our back-end code. It's all JavaScript now. This is kind of revolutionary, really. And this made a lot of our code a lot more efficient, but it also made it easier to write and reuse code. We could use the same exact modules in some cases on both the browser and the server, which is really nice, right? You don't have to duplicate logic. You don't have to worry about validation stuff getting out of sync. It's pretty nice. But I think the most important thing about Node and how it really started to shift us as front and back end developers is that it forced us into the other side of the stack. If you were only living on the front end most of your life, you didn't really have to jump into the .NET stuff or the all that weird C# or PHP or Ruby or whatever it was that your backend is running. But now you kind of had to from time to time. So it just gave us a lot of exposure and started sort of blurring the lines between the disciplines. And I think the other sort of seismic shift was when React hit the scene. Now, if you haven't watched it, I would suggest like going back and watching the talk, the initial, I think it was was it Facebook's React Conf or like JavaScript Conf or something, where the React developers, the initial early React developers at Facebook introduced React to the world, and everyone loved it and lived happily ever after. No one complained, right? No, of course not. Everyone was completely freaked out. What is this HTML looking stuff in our JavaScript? Where's our models and our views and our controllers, right? Like most other frameworks at the time were following at least somewhat close to the trusty MVC patterns. And React sort of just threw that away and sort of started from scratch with its paradigm. It kind of challenged our accepted views of how to structure software. Code that we originally thought of as a view or a controller sort of got mishmashed into one function that we called a component. And React also told us that instead of trying to clunkily keep all of our DOM UI updated to synchronize with our app state, it told us that instead we could just simply build UI that is a function of our state. This was, I think, the most revolutionary thing about React at the time and the way that I thought about writing. I mean, this changed how I wrote apps forever. I mean, I'm still a React developer, obviously, so, but I also still love React. We talk about all these new frameworks, and again, I know this is a mixed crowd, but in the JavaScript world, everyone talks about new frameworks coming out every 5 minutes and all the hype train and everything, but I'm still very much in love with React. I love writing React code. Of course, it gave us some other challenges that we'll talk about later, but I think React really changed the game, and it's still by far the most popular front-end framework that we've been working with for years now. So it's, it's very much a front-end framework for real, but its patterns continue to shift and blur the lines between the front-end and the back-end. Right? We've built now full-stack frameworks on top of React that continue taking these patterns and these blurry lines and further abstracting it. All right. We're going to come back. There we go. And that's where we get to Remix. So Remix is a web framework, and our stated mission is to help you build better websites. It's built on top of React and React Router. Our APIs are designed to embrace the foundations of the web instead of working against them. We believe that browsers are good, actually, and the web is good. All of that stuff I talked about earlier with clunky APIs and weird interfaces for getting and dealing with async data have mostly been resolved, and we've gotten a lot better. Our tools have gotten a lot better. Our services have gotten a lot better, and we want to embrace the web. So we've leaned deep into the standardization and specifications of HTTP, HTML, so on and so forth. And while React is a JavaScript framework, we believe that JavaScript in the browser is best when it is used to progressively enhance the user experience rather than to completely define the user experience. This is something that I feel like, with all the good that has come from our front-end frameworks, I think they've been sorely abused to the point where now many of our applications are completely dependent on JavaScript. And there are a number of problems with that for a lot of applications. Okay, so pause button. This talk is not titled Remix or Intro to Remix. It's about building faster front ends by building faster back ends. So there's a few reasons I'm talking about Remix. The first reason is simply because the conf organizers asked me to. Remix is also my job, and I didn't want to take PTO to fly to Boston. Sorry, I worked these jokes in, and I'm just like clunkily reading off my screen here, but such is technology. The important one, though, is that Remix makes the goals of this talk a lot easier, I think, with our API decisions. So let's talk about some of those. So like I said, Remix is built on top of React Router. Everything in Remix, I like to think of, comes down to the route. Just like in your standard React application, everything's sort of about the component. Well, in Remix, everything's about the route. Right? So this is a Remix route file. Code in this file might run on the client or the server, depending on which module it's in. And we have a number of conventions. So if you export certain modules from an application, they're going to run in potentially different places. So the first function at the top here is our loader function. So if you're route exports a loader. This is an asynchronous function that's going to get called only on the server. This is all code split out of the client bundle. So this will only ever get called on the server. And it is going to run in response to every single GET request. So when a user visits your web page at this particular route, that function is going to get called. And it's going to send an HTTP response that will be received by the client and then handled in the route view. This also works if you're not in a browser at all and you happen to hit that same URL endpoint and say Postman or something, and you just go and actually try and get that data, you can get that same HTTP response. You don't have a separate layer now for some API routes like you might in other frameworks. You can do all of that in your same route. The default export in our route component is the component itself. This is the React component that is going to be rendered on the server initially and then hydrated on the client. So this code is going to run in both places. And the data that is sent from our loader as a response to the client is going to be serialized, and then we are going to deserialize it and access it directly in our component with the use loader data hook that Remix gives us. And so we don't have any asynchronous work going on here. That's already been handled by the server by the time it gets to our route component. So there's no side effects, there's no setting state and dealing with any of that. It's just deserialized data, and now you can work with it directly. And you don't have to manage any of the state involved with that. And yeah, so the data that we send over the networks, the data we get, we can work directly with it in our component. And our route can also handle data mutations. So in addition to GET requests, you can make a POST request, a patch, a put, a delete. Any sort of mutative request will be handled in a function that you export called an action. In this particular action, we take the request, and that request object is your standard HTTP request object. We have no fancy abstractions on it. And we're going to authenticate based on the user session. If we don't authenticate, we're not allowed to do anything, right? You want to authenticate any sort of mutations. And then we're going to validate our data. You always want to validate your data, so we're doing that right there on the server. And again, we're just using the platform. We're using the standard form data API to do that. And then we're going to make a query to our database to actually mutate some data, and then we're going to return a response. And in this case, we're going to redirect with a 302 response. And Remix does have a few abstractions to make things like this ugly response constructor a little easier, because I hate writing those things. I always forget what the actual interface for the code is, so we have a few abstractions for that. So now I want to talk about how does this actually impact us on the front end. So I'm going to do something that absolutely terrifies me every time I do it. I'm going to live code. Bear with me. I'm not a live coder. I've done this on stream a few times, but we're going to talk. Let's just spin up a demo. So I've got this Remix application that is clearly not actually running. So give me a moment and I will run that. Any questions about anything I've said so far before I start writing code? Cool. And if anybody has any problems seeing or anything like that, just ask. I'll try and clarify what we're looking at. So I'm running this Remix app, and I'm at this users route. And the users is simply a list of potential users in our application. This is all stored in a fake database I've set up on this app. And we just got a few users here, and we've got a link here to create a new user. So I'm going to go and visit our create a new user. So let's go ahead and take a look at the code here. Can anyone not see the code? Is this good? All right, if you don't speak up, I'm assuming we're good. Sweet. All right, so in every Remix app, if we take a look at our file structure, your routes are generally defined by your files. If you've ever worked with Next.js, it's very similar. There's a lot of frameworks that use file system routing. Remix also provides a config entry point for your routes too, so you don't have to completely depend on your file system. But for this demo, we're going to be using our file system routes. So everything in our routes directory, you see here, we've got this user's route file. We've also got a user's route directory. When you have a directory and a file alongside one another in the routes folder, the file representing that route endpoint is going to be what we call a layout route. And it's going to be responsible for rendering and loading the data for everything on that route, as well as all of the nested child routes. Remix supports nested routes. They're really freaking cool. Don't have time to talk all about them, but we will explore a few reasons why I think they're cool. So this is our users route. This is what we see when we go back to users. We see that we have a loader function that we're fetching some users in our, from our database, and we're returning a response. This is our JSON helper that just sort of abstracts that new response API that I just showed you, and it serializes and sends that back as a 200 response. And then we are loading those users via useLoader data, everything we just talked about. I've got some other stuff here we'll talk about in a few minutes. And then we're just we're looping through the users that we get back from our database and rendering a list. So that's what you see here, right? But I said we have nested routes. So if I go to create a new user, and I go into my users directory, and I go to the create route, and see this is what we're looking at. We've got a form now, and we still have the list of users. But our component doesn't actually render the list of users. It only renders the form. That's handled by the parent route. Again, these are nested routes. Our layout route is responsible for both that endpoint as well as everything underneath it. So we only have to render our users once, but we also only have to fetch our users once, because those data loaders are also called concurrently. We call all of our loaders on nested routes concurrently, so that's an optimization which is really nice. We don't have to worry about network request waterfalls, which can really slow down your application. So we don't even have a loader in this function, but we do have an action. So the task that we want to undertake today in this demo is wiring this up so that this form actually creates a new user. These are all people that I either work with or used to work with, so I'm going to go ahead and put, this is not, does anybody know who like Michael Jackson is, you know, the singer? All right, well, I work with a guy named Michael Jackson. It's a big problem for him, yeah. And I'm going to actually get out of here so 1Password doesn't kick in and start making things annoying. All right, that's better. Let's do that again. Let's see, what is his GitHub? I'm going to steal his profile picture. Oop. That's his avatar, and he lives in Carlsbad, just down the street from me. All right, nothing happens. We click the link, nothing happens. We want to make this work, so what do? Well, let's go back into our create user function and see what we're working with. We've got this form thing. This form, where's the form component coming from? Anybody know what a form is in HTML? Cool. Do you ever use them? Like, you know, how you're supposed to without event.prevent default and then client side load some data? It turns out I sort of even forgot how to write forms after a period of time. Like I said, it was all kind of weird. You had to go into your backend and intercept the requests, and who has time for that? Let's just make a fetch in the client and go home. One really cool thing about Remix is we get to go back to how we used to do things in some ways. And so we've got this form component. Does anybody use React Router? You know how React Router has a link? Does anybody want to tell me how link works? At a very basic level. Now, why do you do that instead of just using an anchor tag? It's a single page application. An anchor tag is going to reload the page, and that sort of defeats the whole point, right? It's also nice in V6 React Router, because with nested routes you get relative path matching too, which is kind of nice. But primarily, yes, it's because we don't want to reload the whole view. Form component works basically the same way. At the end of the day, what is a link if not just a form, right? It's a thing that you click that makes a GET request to a new URL. And when you submit a form, what do? You post or get to that action in the form. So it's kind of just an abstraction. A link is kind of an abstraction of a form. Maybe a form is an abstraction of a link. I don't know. It's kind of metaphysical. But our form component is going to behave similarly to our link component in the sense that if you were to submit a regular form, it's going to redirect to whatever your action attribute is. But since we're on a single page application, once we progressively enhance the page and JavaScript is loaded and we do all of our fancy things, we can actually avoid that page refresh and just get the data directly as if we were fetching it, right? And never have to worry about janky UI. So that's what our form component's doing. And we are posting to, where's our action? Well, if we don't have an action, if you think of an action as your href and a link. If you don't have an action, you're going to post to the same exact route. So whatever route you're on, you're going to post to. So we're going to post, and it's going to call this action function. And so when we call the action function, we've got this artificial wait to simulate a slow network, and then we're going to return some response, right? But what we want to do is we want to start mutating some data. So I'm going to go into my action, and the first thing I'm going to do is I'm going to turn off Copilot so y'all don't think I'm cheating, and also because it's probably going to be wrong. So let me go ahead and think about what we're going to do here. So we've got a request object. When we send a request with a form, it's going to come with some form data. Whatever we've submitted in the form fields, we can get as form data by calling the request.formData function, which is asynchronous. So once that form data has been processed, we'll get it back. And this interface is quite nice. So all of the fields that we have, we're going to say my name field is form data. Why is get? I thought I turned you off, Copilot. Go away. Let's try that again. I love Copilot, but it's annoying when I don't want it to be on. So form data.get, and this is our name field. We have a name input down here, I believe. We also have a, you see how I've cheated up here and put the comments as to what my field names are. So we've got our avatar URL is going to be form data.get.avatar URL. I'm just going to repeat that for the alt text. And we've also got our hometown field. All right, and so now we've got some data that comes into our form, but now we need to, anybody want to guess? What are we doing here? We're creating a user, so I'm going to construct a user, but I don't know what the data is. I'm using TypeScript. If you're not a TypeScript developer, I'm just declaring a type here. If you're not a TypeScript developer and you're in this room, it means you're probably a C# developer. And if you're a C# developer, you already know about types. So I'm just going to say we've got an unknown type at this point because we haven't validated anything. I'm going to say we've got this avatar URL. And we've got this hometown. Oops, I did not do that right. All right, beautiful. Now I've got the nice validate. I think it's is valid new user. If not valid, what we want to do is we want to handle this error. If this is invalid data, we can throw a response. I'm going to throw a response that basically says we've got invalid data, so just a 400 response. Remix really forces you to learn HTTP codes, as it turns out, which is a good thing, but also annoying if you've been doing things the wrong way like I have for many years. All right, so now we've validated our user. We know it's the right type. So when we create a new user, we're going to return it in the response, and this is a 200 successful user creation. But we haven't actually created it yet, so I'm going to say this is actually just our user data. Our real user is going to come from the create user function that is going to make the query to our database. And then we are going to return the newly created user as a response. And so now, if we're lucky, we can go back and make sure I didn't screw anything up. Let's try that again. Oh, am I still not in? Yeah, I want to stay in incognito mode just so I don't have to worry about things like autocomplete. All right. That's still going to give me autocomplete, isn't it? Whatever. Pop his avatar in there. And get a bad request. What do we do here? Let's go and check see if we got any typos here. So we got a name, we have an avatar, we have a URL, we have an alt. Let's check our isValidNewUser function. We'll check a name, avatar, avatar.url, avatar.alt, hometown. Form data get. Did I spell these things right? Anybody see anything I may have done wrong here?
I didn't see where the avatar alt is coming from on the form.
Oh, yeah, no, totally, you're right. So what I meant to say was we don't, good call. Let's see, avatar alt is actually, we'll just say this is we'll use their name let's say avatar. We could probably create a form field for that. That would be better. All right, let's try that again. This is why pair programming is good.
Thumbs up for the accessibility though.
Yes. Very important. Let's try again. Boom, there's Michael Jackson. Cool. So now he's a part of our team. Great. Does deleting anything? Oh, no, not implement. We haven't implemented the delete, so we can't delete him yet. Next thing I want to implement really quick. How much time we got left? Timekeeper.
20 minutes.
20 minutes. Sweet. Plenty of time. All right, so next thing we want to implement. Any questions about what we just did, by the way, in our action? We feel good about forms now? Feel better about forms than we did 10 years ago? I hope so. That's our goal anyway. That's my goal. I want to make you feel better about forms. So next thing we want to implement is we've got this hometown field is actually, it's actually a combo box. So what we want to happen here is we want to get a list of cities, and as we type, narrow down the list of cities and have you be able to quickly populate those. And what this is doing, if we take a look at our combo box field, this is using the combo box from a library called AriaKit, which is very good, highly recommended. Accessibility first focused library to build very complex UIs. So this combo box is going to have a popover, and it should display a list of all of our cities. Now, what we actually want to do is when the user types into that field, we want to hit our database to find the list of cities. There's actually a ton of cities, and we don't want to send that entire list of cities as a static payload for every single request, since we only care about like the top 10 cities that match against what the user is actually typing, right? So we want to offload a lot of that work to the server, and so when we start typing, we'll narrow that down. This is a great example of progressive enhancement, by the way, because if JavaScript hasn't loaded, this is just a straight up text field. So it still works, you can still submit city data, you just don't get the fancy popover. Cool, so what are we doing here? So when we change on our combo box change, we're calling this cityfetcher.load. What is cityfetcher? So useFetcher is a hook that Remix gives you. It's similar to useLoader data in a sense, except for what we're doing here is we're not requesting data from any of our loaders. We're actually setting up an object that we can use to make requests to other routes, to outside routes without navigating the page. So I talked about the form component. The form component is going to post to a route and then redirect you to that route. But in some cases, you just want to fetch the data, right? You want to make a client-side request and not actually worry about navigating after the fact. So if you want to not navigate and simply request data from another route, you can do that with a fetcher. So we call useFetcher. This comes, again, from Remix. And then when we change the input, we are using the fetcher and its load method to actually request some data from another route. So we are loading data from the search route, and we're passing a query param. So let's go ahead and take a look at that. So this is cities/search. This is going to correspond with the cities.search file. If you don't actually nest the directories, you don't have to nest the directories if you don't actually need nested layouts. We use dot delimiters so that you can nest URL structures without actually creating nested hierarchy of routes. So looks like I left all my cheat code in here, so I'm going to try not to cheat. So we're waiting, and we're not really doing anything here, which is why we don't get anything from our combo box. So let's go ahead and fix that. So what I actually want to do here is I'm going to go ahead and construct a URL object. Let's say new URL comes from request.url. Right? This is, again, using the platform. And we want to look for our query string, which is going to come from a search param based on, or passed into our endpoint. So url.searchparams.get queue, and we'll just say default to an empty string so that we don't have to. And ordinarily, again, you'd probably want to validate this, but it's not really that important for this particular case. And so we want to fetch a list of cities. So I'm going to say my cities are going to come from I think I have this search cities function that is going to be asynchronous, and this is going to hit our database to make that request. And we're just going to pass it our query. And then once we get that, it's going to come back as an array, and we're just going to only worry about I have this max results. We're going to take the first 16. I like multiples of 8. Some people do 10s. That's fine. We're going to return the first 16 results from that. So we're not sending not sending the entire payload back to the client. We're just going to send them the first 16 best results. And then we are going to return a new response. And I'm going to just return some JSON here and say, I'm just going to pass the cities directly. And again, this is a 200 response. And then I added some cheat code here because I was never going to remember how to explain this live. But anybody know what cache control headers are? Anybody? We got one. Tell me about cache control headers.
The headers tell you, I believe it at least tells you whether to cache the data or whether the data should be cached. I don't remember which one it is.
Yeah, I mean, essentially, it's basically the server telling the client what you're allowed to cache or not cache and how you should cache it. What are the rules of caching? Certain data you want to cache for faster response. Certain data you might not want to cache because it might have some sensitive information. It might be intended to be short-lived. It might be invalidated very often, so you don't want to cache it for very long. So the cache control header is how we essentially tell the browser what it should do. And if we think about this for a second, we're typing in a combo box. Every single keystroke is going to make a request. That sounds like it could get really slow. But why would we need to make a new request for a query that we just did? Say the user backspaces, and now when they backspace, you're basically back at the last request you made. If we cache that data, you don't have to make a request again. It's already in the browser, right? So we can tell it via cache control header that we only want to cache for max. We want to be able to cache this response for a max age of 60 seconds. This is just an API for constructing a cache control. I'm going to double check to make sure that's right. Oh, sweet, I got it right. Cool. So yeah, we want to cache it for 60 seconds. So while I'm typing, for the next 60 seconds, if I've already typed in something, not only is it going to come, do I not have to hit the database again, it's just going to happen instantaneously because the browser already has that data, right? And we'll see that in practice here in a moment. So if I go back to my app here, so I'm going to start typing in my hometown here, and I'm going to type Carlsbad. You see I've got a little loading spinner. Takes a couple seconds. I'm going to select Carlsbad. I'm going to backspace out of that, and I'm going to start typing again. CAR, instant. So we've sped up. This is the one thing I want to call out is like I'm actually talking about the title of my talk right now. We've sped up our front end because we've sent the right headers from our back end. Very important here. So now that works. The last thing I think I want to do is this delete functionality. I want to be able to pull Michael out of our team members. So we need to implement the delete route. Any questions about what we've done here in our search, by the way? Yes?
Is the concept of cache control, is that a specific remix thing?
No.
Or is that just web?
That is the web. That is web standard. There's an MDN document that explains cache headers. Tons of cache headers. It can get a little rabbit holey, so I would definitely highly suggest looking into some cache control headers. This is actually a very important concept in Remix. A lot of other frameworks in the React space, Next, Gatsby, lean heavily on delivering static content. Because static content, if it's static, it's just an HTML file. You don't have to do a bunch of work on the server. You can just send it, right? And so we think by default, static is going to always be faster, but that's not necessarily true. Cache control headers go a long way in speeding up server-rendered applications. So we think cache is difficult, but in reality, it's just a fundamental piece of the web that makes building for the web, building dynamic applications for the web, much easier, much faster. So yeah, good question. Any others? Cool. All right, last task. We're going to delete Michael. I'm firing Michael from our team, even though he's my boss. All right, so what I'm going to look at now is let's go back into my users route, or no, in my create route. No, it's in my users route. I had it right the first time. So in my layout route here, I've got another fetcher. I've got this delete fetcher. And in my delete fetcher, I think I missed one thing in my create. It's fine. I only have 10 minutes left, so we'll just go straight to delete. So delete fetcher, we've got We are rendering a delete fetcher.form. What the heck is that? The fetcher's form is exactly the same interface as our standard form that we imported directly from Remix, but the fetcher comes with its own form because, again, you don't necessarily want to redirect after you're done with this request. You just want to load it there on the same route. The really cool thing, I think, about the fetcher's form is that, again, from a progressive enhancement standpoint, if the JavaScript hasn't loaded yet and you submit this form, the response can still send you some UI. So again, you can still use the application. You can still get the response. You can still execute that query on the server without ever having to load the JavaScript. User can have JavaScript turned off. It could have just not loaded yet, and your app is still interactive, which I think is pretty cool because as long as it hits this endpoint, even if it does that redirect, you don't get the fancy single-page application experience, but you still get a functional application, which I think is very, very cool. So we're rendering a form over top of this delete button, and we just want to hit this endpoint. So it's user/delete/user ID. In Remix, we can do a dynamic route parameter with this $sign. This is another one of our conventions. So delete $ID, that tells us that we are passing an ID param to our actioner loader. So I'm going to get rid of this guy. I'm going to keep the waiter in there just so I have a little bit of, we can see some waiting in action. So I'm going to say what I want is I want my user ID. And this is going to come from the params that I get as provided into as one of the arguments in action. Say params.userid. I'm going to validate and say if we don't have a user ID or type of user ID is not equal to string. So let's go ahead and validate any inputs. We are going to throw a 400 response. Or we can just put some All right, so now that we know we have a user ID and it is a string, I want to go and fetch a user. So I'm going to say users equal to wait.get user. Oh, no, I'm going to wait.delete user. This is also just a database query that I've set up. It's going to pass in my user ID. And I believe delete user, if it's successful, will give me an actual user to return, the one that we just deleted. And if not, if we don't get a user, again, I'm going to throw a response. And this is not 400, this is a 404 because we have not found, right? User not found. All right, and then of course, if we do have a user, we're going to delete it and then return it as our payload. And 200 is default, so you don't even actually technically have to pass 200 there. All right, let's go back to our app and see if we can delete Michael. Michael, you're fired. No, bad request. See. Oh, good call. Yeah. So what's so another cool, just to back up from that, it's a good stop point. But in Remix, we have this another concept of error boundaries and catch boundaries. So when you throw a response, you can actually completely bail out of your route altogether and handle that in a separate component, which I think is pretty cool. So if you throw a response, it's going to throw an error in your application. It's going to be caught in one of your boundary components. You can also return a standard 400 response if you want, but you'll stay on the same route. So that's sort of a distinction there. Really useful for like unauthenticated route access and that sort of thing. So yeah, that's a good call. So let's see if we can delete Michael now. No. All right, so no user. What are we doing here? How are we getting the, no, what do? We log it. All right, what are we? Undefined. What the? Oh, it's params.id. Ha! All right, now you're fired, Michael. Michael's fired. He's gone. Sweet. We submitted a form. Michael's gone. No longer on the team. And that's Remix. That's Remix actions, loaders, and everything I got for you because I think I'm out of time. With the last few minutes we do have left, questions? Yeah, there's loads of benchmarks between Remix and other frameworks, if that's the kind of thing you'd be looking at. But in general, if you're talking about when you say the old way of doing it, you mean like client-side fetches and stuff like that. That would be a difficult one to benchmark because your client-side, so there's a couple of things we have to think about here. When you're fetching on the client, you're dependent on a couple of things. You're dependent on your client's hardware, which you have no control over. You're dependent on their connection speed, which you have no control over, and you're dependent on, of course, the server that you're requesting data from, that you do have control over. So when we move everything to the server, all those data requests to the server, we're narrowing the things that we have to actually think about when we think of performance. So I'd say it's probably going to be a difficult one-to-one comparison, simply for that reason alone. You're just delegating responsibility from a device you don't have any control over to one that you do. But I will say that what's more important than loading data on the client versus loading data on the server is loading data at the route level versus loading data or fetching data in the component level. If you're using a library like React Query or some like advanced fetching, data fetching libraries, you probably won't run into this problem as much because they handle a lot of that complexity for you. But if you're just doing raw fetches at the component level, think about the component hierarchy. Think about if I'm fetching some data here, I'm also fetching some data here, I'm fetching some data here. Each one of those requests is going to be blocking. So you've now introduced a data request waterfall where you have to wait on one request to be fulfilled, and wait on another to be fulfilled, then wait on another to be fulfilled. And this is where you end up with loading spinners all over the place. So moving all of those requests up to the route level, not only are you moving them to the server, but you're moving them into one place where they can be handled concurrently, which again, Remix does for you by default. We really think that making those sort of optimizations the default behavior is going to just increase the likelihood that you're going to do the right thing. So, other questions? Anyone hate it? Anyone still hate React? Oh, come on, I need some strong opinions here. There we go, we got one. From the guy who just gave a talk about not using frameworks, I think, so. Sweet, well, I have nothing else. I hope you enjoy Remix, and I hope you use it and play with it. And if you have any questions, grab me afterward and let's chat. Appreciate it.